So hello everyone, welcome to our next class of our radical chemistry. So this is class 2. In previous class we have discussed about the radical generation and in a little bit of history. Okay, so in this particular lecture actually we are mainly interested about the basics of radical chemistry, like what is radical and how it is differentiate. How can we differentiate this radical with any kind of carbocations or carboanions? Okay. So first of all, that radical, free radical is a species which have a single unpaired electron. Like this is our radical system, and this is carbocation and this is carboanion. Like we have to know that what is the main differentiating feature of a radical and a carbocation and carboanion. If you see about carbocation, you can see that there is one positive charge is there, and the overall species is a 6 electron system. And due to this particular species will attain a sp2 configuration, and thus it is a planar, and it contains 3 bonds and it contains a positive charge. This is a carbocation. But in the case of radical, it is a 7 electron system. One electron, which is a single unpaired electron, is extra in radical system, and it is also planar, and it also contains 3 bonds, but it is a neutral charge because this particular p orbital contains one unpaired electron. But in the case of carboanion, this particular p orbital contains 2 electrons, and to maintain the valency it contains a negative charge, and this particular overall species is the 8 electron system, and it is a non-planar system. It is a pyramidal one, and it also contains 3 bonds, and when there is a one particular p orbital there, it contains two excess electron, and it contains a negative charge to maintain their valency. Okay, so now let us talk about representation. Radical can be represented by a dot over the atom, and the reaction shows by using a single brav arrow. So here it is a radical that I already discussed in our previous slide. So now the radical reactions are mainly denoted by this particular arrow. The normal arrow is something like this, but the single brav arrow is looking like this. Here you can see. Okay, and here this particular Cl2 in presence of photochemical scenario like H nu, this particular bond has been homolytic cleavage has been observed, and this two different radical or two chlorine radical has been formed, and this single branched arrow, that is this arrow shows the movement of one single electron. So whenever you are writing the radical reactions mechanism, you must use this particular single branched arrow. Okay, now let us discuss about methods of radical generation, like how a radical can be generated. In principle, radical can be generated by two different methods. One is the thermal generation and one is the photochemical generation. So in thermal generation, the particular compound has been heated to a higher temperature, and all of the bonds having their own bond dissociation energy. Like when we are actually heating the particular molecule, and when the heat energy is enough or it greater than the bond dissociation energy of a molecule, then homolytic cleavage has been observed, and thus result in the formation of two radical species. And in photochemical generation, the radicals are irradiated in presence of UV light, and we all know that UV light having a higher energy over any kind of lights, and due to this particular light energy, it when it will be matches or it will be exactly greater than the bond dissociation energy of the particular molecule, then the bond has been broken and two radical uh, or the formation of radical has been observed. Now let us deeply talking about the thermal generation of radical. Like usually it has been observed that when we are actually generate a radical by a thermal method by using heating method, so what happened that it often requires high heat, like very much high temperatures required to generate the radical, So to overcome this particular part, because in laboratory process we are actually limited to the heating condition, so we need something that we can decrease significantly decrease the heating or the high temperature. So this particular thermally radical can be generated by the help of initiator. Now we must be talking about that what is the initiator. Initiator is a compound that decomposes in presence of a low amount of heating to produce free radicals, and these particular free radicals are then used to break our resultant molecule to form the particular our desired radicals. So these particular free radicals which can be generated from the initiators, this initiate a chain reaction with our targeted molecule, particularly in the polymerization process, and we got our desired radicals. Okay. Now the advantage of radical initiators are, first one, it is the enable controlled polymerization, which result in a uniform and predictable molecular waves. And also it allows precise control over reaction condition through temperature flexibility. Like I already discussed that in case of a normal thermal generated radical, it requires high temperature. But when we use an initiator, then the temperature requirement is drastically reduced. Like in previous, if the particular radical can be generated in a 500-degree temperature, now by using initiator, we can reduce it to 100-degree temperature, and that is a much more achievable temperature in laboratory process. Okay. And also the radical initiator are effective in diverse solution and environment, which makes it suitable for various applications. Now with this we have to end this particular class. So in this particular class we are learned about what is the radical actually, and how it is differentiate from a carbocation and carboanion. Then we have discussed about how to represent a radical reaction by using the single barbed arrow, and then we are talking about the methods of radical generation. We are briefly discuss about two methods of radical generation. One is a thermal generation and one is a photochemical generation. And we are talking about a very little about radical initiators. Now in our next class, we are talking about radical initiator in an elaborate way. So thank you for listening.